Alright, let's start. So we have discussed the monoalphabetic cipher on last day's class, where we discussed a specific arrangement that there can be more than one mapping that may be done with respect to the letters, and we have observed that in that way we can reduce the brute force attack. But ideally, when you come back to the frequency analysis, we have found that instead of, like, if you consider more than one letter together, the diagrams and the trigrams and all, we were able to decipher the data without even looking at without even knowing the key, and also without even knowing the pattern of the data set and all. But we were able to at least find a skeleton of the data message. Okay, so that was the biggest drawback of monoalphabetic cipher. Keeping that in mind, the next thing that comes to our idea is a polyalphabetic cipher, which is something which is little different, I would say, compared to the other existing technique. Because here in this process you will find that we are going to introduce some of the rules in making the key specifically to key, not the plain text or the cipher text, specific rules on top of the key, so that we can arrange the key in a way that the brute force as well as the frequency analysis process itself gets a little more secure, and we are having a secure communication between the samples of information. In that, the first of the easiest technique that we come across is called as Vignere cipher. Alright, so let's see how it is done. And the process involved is also very similar. You can see the equations are almost same as that of the additive cipher. So as for the equation is concerned, that's not a very big deal in that way. But the process what is involved is something different. So let us start with that. So what happens usually, that given a plain text, okay, see a table for you. I'll go, in fact I'll show you this table, that will be better. This is one of the first methods in Vignere cipher. There are two ways of doing it. One is using the table, and the other one is without using the table. So we'll discuss both. The first thing is with the table. Now if you observe this particular table, you come across that the x-axis that we are looking at, we have a plain text somewhere over here. We have a plain text somewhere over here in the x-axis. On the other hand, in the y-axis we have the keywords. You can see the keys in the y-axis here. Now how usually it happens is that for a given plain text, we will arrange the plain text just like any normal given plain text, and the key also we will select as per our wish. But now what we are going to do is, we are going to encrypt the data in a way following this table where the plain text and the keyword intersects. For that matter, for example, suppose my I'll write it down here, or maybe I'll do one thing. I'll just take this. Control C. Just give me 1 minute, so that it keeps here. We can look at it and we can solve it. Is it visible at the back? I don't think so. Okay, it is just a reference. I'm just trying to keep it so that we can do it all together. So for example, I have the plain text as give money. So suppose I have a plain text, give money. This is my plain text, and my key is lock. L-O-C-K, lock. Now this can be any example. This is only one of the case. Now if we are following the table rule, what we are going to do, we are just going to see, we will arrange the plain text in this way: G-I-V-E-M-O-N-E-Y, and accordingly we will also arrange the keywords. How? L, suppose this is my table I am making. Just follow this very carefully. This is something different to that of what we have discussed so far. Now, this is a plain text I am arranging. Now, the keys need to be arranged in a way such that even if it is is required, it will repeat itself. Like we will mention lock over here, L-O-C-K. But if you observe, the rest of the elements are missing. So what we are going to do, we are going to fill it up also, L-O-C-K. We will go on repeating it. And you can also observe the last one, the Y that you are looking at is still missing. So we will go back to L once again. So repeating once again what we are trying to do, we are using the Vignere circular but using a table. The table is given by there, which has a specific arrangement where the plain text is given in the x-axis and the keywords are arranged in the y-axis. Basically they are A and A to Z only, arranged in a different order. Now what we are trying to do is that for a given table, we are making a table in which we are first writing down the plain text letter by letter. So give money is our plain text, we are writing it one by one. And now we are arranging the key in such a manner that even if it is required, we will repeat the key again and again until the plain text and the key set are of the same dimension. If you observe over here, lock had 4 data, L-O-C-K. So we are repeating it second time lock. Okay, so maybe is it visible out there at the back? Is it fine? So L-O-C-K is again repeated with L-O-C-K, and then on the last end for the money Y, there was no letter, so we will again repeat L at least. So given the fact that if you have a longer plain text and if you have L-O-C-K, so you will go on repeating it again and again. That's the process. This is the arrangement of the table with respect to Vignere cycle. Now what we are going to do, we are going to back to the table once again. We are going to figure out that with respect to G as a plain text and L as the keyword, where they intersect. So for example, you can observe this is my G column. I'm just noting it down over here. G, and this is my L column over here. Please tell me if you can able to see it or not. Okay. So now if I happens to go by this way, 1, 2, 3, and you come across somewhere over here. If you observe that if I go down from the G column from the plain text, and if I go row wise from L, it will intersect somewhere around R. So basically my G and L, the cipher text would be R. So this is only with respect to G and L. G is the plain text, L is the keyword, and we are getting from the table that the cipher text or the cipher letter in that way is R. Can you tell me for I and O, how will it be? I is over here. I'm not sure whether you are able to see the table. I'm not very confident actually, but if you can. I is over here, O is over here. So maybe I will go and do it. Right? W. So basically we can say the cipher letter will be W for the set I and O. Am I fine with this? Similarly, you can go ahead with all the other segments as well. Can you quickly do it and tell me at least 2, 3 by looking at the table? What will be for V and C? V is over here, C is over here. So somewhere over here it comes and intersects X. So X is for the combination V and C. Space means? Oh, this one? No. That won't be done. Space doesn't have any role in particularly for this kind of an entry. We will see that later. It will come. But here, as we are focusing more on the letters and alphabets, to be honest, and substitution methods, so in this case, the space won't be a factor over here. Okay, we have to consider in a way, as you can see in the table when I form, give money, there is no space in between. So it's a continuous letter that we are talking about. Right? So basically, if you can finish it off and tell me the cipher text that you are getting, 3 letters we have got, R, W, X. Can you tell me the rest of the elements which we are getting? Alright, so maybe I'll write R, W, X, that's what we have got already. Then O, X, C, T, O G. Correct. So if you go back to the table and you go on checking it, you will find the rest of the ciphertext just like that. So it's a relatively simple process, except that you need to know the table, you need to have the table in order to solve it, and that itself is a little bit of trouble process, because you always know the table and you can find it out quite easily at what the resultant encryption is, because the decryption will be opposite to that. Simple as that. The decryption will also be the same, right? So in decryption, what will happen? You go to R. Like for example, R you take. So because in decryption you are trying to decrypt the letter with respect to the keywords given. So in that case also the same thing will happen. You can see that the ciphertext is R. So somewhere over here R. Okay, and you have L over here. So if you go back, table, that entry that you are looking at, that's basically your ciphertext, right? So the circle I was missing again. I was searching this one. Yeah, so we go by R, and wherever it intersects, we go up, and we find out that the plain text is over here. See, that's what I think the doubt was. So basically, we know the key, we know the ciphertext, we have to go back to the encrypted, the plain text. So the entry which you are looking at the table, guys, please concentrate. Whatever you are looking at the table is basically your ciphertext letter. So based on the key, you go right hand side, wherever the ciphertext comes in, which in this case is R, go up towards the plain text column and you find whatever the letter we have, and that will be replaced by the plain text. So that's what we are going to follow. Since already I had circled this one, I got confused that I was searching for this G. Okay, because there is another G over there, and that's where the mistake was coming. Good. So in that way, we can just decipher the data what we have, and we can find it out for any set of plain text. But as I can observe that over here the table is a factor which we need to bother work with, and we have to carry this table always. So for that there is an option of no table approach. Okay, there is no need of any table. So let's see by this example. In that itself, we will need the encryption formula as I already had told you. So let me just write it down. EI is equal to PI plus KI mod of 26. So this is for the ciphertext, and for the decryption I'm just writing it down. I don't think we are going to use that much except for the calculation, and since we already had done it, so EI minus KI mod of 26, because the calculation part is almost same as that of the previous example, so we can skip that part, to be honest, but the arrangement without any table is what we are going to discuss now. So this is without table. This is a without table concept of Vignere cipher. So what we have is that we have the plain text, suppose as she is listening. This is my plain text. She is listening, and again the same thing, the space doesn't have anything to do with here. She is listening is the plain text, and we have a key which is Pascal. Okay. Even here also, don't consider the capital letters, small letters, those things are not factored here as such. Where the algorithm is what we are looking at. So the plain text and the key is provided, and we don't have a table. We don't need the table. Okay. So what we have to do first is that based on the previous arrangement of 0 to 25, that arrangement of letters, we have to find the numeric equivalent of the key. By that what I mean is, if you go back to the table, that 0 is mapped to A, 1 is mapped to B, and all those things, P will be 15, A is supposed to be 0, S is supposed to be 18, then 2, then 0 and 11. So this step particularly indicates for any key, you are going to replace that by the numeric equivalent based on the generic table that we already have for the Caesar cipher, from the days of Caesar cipher. 0 is mounted to A, B is 1, C is 2, like that we have arranged. Now, This is a normal substitution process. Now we have to form a table. How we are going to form the table? The table will be formed something like this. Let me just do one by one. So first thing is plain text. First is the plain text. So we will write it down. S H E I S. She is L I S T E N I N G. She is listening is what the word for the plain text we have arranged. Now we have to numerically write the equivalent to the plain text as well. So please make a note of this. So I would say value over here. So the plain text numeric equivalent value. Okay. Can anyone please tell me what was S? 18. So same way 18, 7, 4, 8. Then S was 18 once again. L was 11, 8, 18, 19, 4, 13, 8, 13 and 6. So maybe I'll just put a block over here so that it becomes unique. 11, 8, 18, 19, 4, 13, 8, 13, 6. Right? Now we have to do is, we have to write the key in terms of the numeric equivalent, which we have already mentioned. And remember the process that we are going to repeat the key if required. So here, so key value I'll write. So 15, 0, 18, 2, 0, 11. Now after that there is no key available. So we are going to repeat again. So we will start with 15, 15, 0, 18, 2, 0, 11. Again we are left with two blank column which we need to fill it up. So we are going to repeat once again. So 15 and 0. So basically in this particular example we are not considering any of the table, and we are trying to encrypt and decrypt the process. Okay. Done with it? Now you have the key. If you go back to the formula first, if you go back to the early formula that we have over here, Pi plus Ki mod of 26. Simply what you can do, you have the Pi. What is Pi? 18. What is Ki? I means here first element. That's why I has been mentioned. So you have 15. So what you have to do? 18 plus 15 mod of 26. Whatever the residue you are getting, that you have to mention back to the table once again. So I'll write that as the cipher value. C value indicates cipher value. So can you quickly tell me 18 plus 15 mod of 26? 7. So I'll fill it up again. 7. 7 plus 0 mod of 26. 7 divided by 26. So 7 again. 4 plus 18. See the column. 22 divided by 27. So 22 once again. 8 plus 2, 10. Residue will also be 10. 18 plus 0, 18. So 18. 22. Then just add up. 23. 18. Now 19 plus 18. 19 plus 18 mod of 26 then. 11. Okay. Then 6. Then 13. Then 19. Again 15 plus 13. Again the same thing. So 7 should come. 7 or 2? 2. 2. and 6. Now what we have to do? We know the cipher value. Go back to the previous table, the generic table that we have. Convert this to the alphabetical equivalent. So 7 will be 8. Good. So cipher text I am talking about. H. 22 was W. 10 was K. 18 was S. 22 is W once again. 23 is X, S, L, G, N, P, C, G. So this is a process in which we are not utilizing the table, the Vignere table that we are referring to in the previous case, and we are able to encrypt and decrypt the process. And this is the encryption. Decryption will indicate the same thing except that we have to take the EI value, that is the ciphertext value, and we have to subtract that. Can you just see it for yourself that whether it is like whether you will be able to do that? You go back to the equation once again. Equation was EI minus KI mod of 26. EI is basically the ciphertext value, the encrypted value. So that is this value, right? So accordingly 7 minus 15 mod of 26. That will be the first letter. 7 minus 15 mod of 26. What will be the value? Minus 8. We can't take minus. We have to add 26 to it. Whatever you are getting 18, you see the plain text is 18. We have already mentioned the first row. 18 corresponds to S. So we get that. Any doubt with this? Anyone? Wait. Any doubt? Last minute. Please check once again that if you are able to comfortably do it. So in table what we are trying to do, we have a fixed table. Based on each, one thing to note, the key needs to be repeated if at all is required. Until and unless the dimensions are not equal. You can see here also, the dimension of the plain text and the key are same. If that is not you are doing, definitely there is some mistake you are making. In case of table, we had a reference. Based on that, we found out the ciphertext. And from the ciphertext also we can take back to the plain text using the process. In that, typically we are dependent on the table. But here we don't need the table, specific table. We only are using the basic table that we all know of the arrangement of alphabet to numeric value. Based on that, we are going to find out. But remember here, the equations are very similar to the additive cipher. Same thing, except that what can be the difference in with respect to the additive cipher and this one? In terms of the equation or the process that we are using, can you tell me? With respect to the additive cipher, there also we are using P plus K mod of 26, same thing. What is the difference from that process and to this process? The key sets are different. In that case, the key was constant, or everywhere you are using K equals to 3, K equals to 7, and it was getting added up to every letter that we were coming in. But here, every time there is a new key that is being added. That is where it is making things a little bit more secure compared to the normal serial. Right? So this is about the Vignere cipher that we have discussed. But this is not only the one polyalphabetic cipher that we have. Another very interesting polyalphabetic cipher that we have is this one. What we call as Playfair cipher. It's very, very interesting. And there are certain rules associated with this particular process. So I want all of you to please make a note of these rules very meticulously, because without which you are not able to solve them properly. It's a little confusing, so focus on it carefully. I'll try to explain as simple as possible. So first of all, the step is, so anyway, the history behind that is that in Charles Wheatstone he actually proposed this idea, but at that time it was promoted by Lord Playfair, and that's why the name comes in for Playfair cipher. So that's the name of it. Now what happens is here we are going to utilize the process of diagrams. Remember the diagrams we had utilized in last day's class also. So two digits that we are going to take, pair of digits we are going to take, and we are going to use certain rules in order to encrypt and decrypt the process. So if you observe the first thing over there, the algorithm has two basic steps. First is generate a key square of 5 cross 5 dimension. Nothing, not 6 cross 6, not 7 cross 7, nothing else, 5 cross 5. It should be a square matrix of 25 elements. Second part, algorithm to encrypt the plain text. There are certain rules, actually there will be 4 rules based on which we are going to define the encryption. Okay, so let's see one by one. First of all, the first step, okay, how it is to be done. So if you closely observe over here, monarchy is the keyword that we are looking at. You can see that at the bottom it's mentioned. Monarchy is the keyword that we have for a particular Playfair cipher. And see the arrangement that we have made for the table. If you carefully observe that MONARCHY, this is where our keyword ends. But unlike to the previous ciphering process, you can observe over here what is happening, that we are arranging all the other 25 letters based on which letter has not been yet used. So if you observe, already in monarchy, A has already been used. So the letter that we are substituting over here, okay, is B. So we are starting with filling up with the rest of the alphabets which has not been used in the key. So if you observe, B is over here, then D. Why? Because C has already been used over here. So A is not being used, C is not being used. Then you can see E, F, G. The rule is I and J, because to make it 5 cross 5 most probably, I or J can be alternatively used. That's why you have mentioned I and I/J. Any one can be used. That's the rule. So I, J, K, L, then N is missing. Why? Because N has already been used here. Understood? N is again missing because N has already been used here. N, N, O. O is already been used over here. P. So L, P. Q, R is missing again because R has been used here. S, T, U, V, W, X. Y again is missing because Y has already been used over here. And Z. Yeah, so for any given keyword, you actually can make sure that what should be the nature of the table. Can you quickly do it for Pascal, the keyword that I have considered? Can you make the table for me? Let me just do that together. So the keyword is Pascal. Okay, so we have to have a 5 cross 5. So P A S C. Now we have A once again, already A being used. Alright, Pascal we have already used. So we are going to use L. Okay. So based on that, B, D, E, F, G, H, I, J, K, L is already used. I, J, K, L, M, N, O, P is already used. So Q, R, S is used. So T, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so in all probability this will be the table that we are going to follow. So it is for the particular keyword. So every keyword will have a certain degree of table that we are going to follow. So that is basically given over here. This is for a specific element, same goes for anyone. So this is the first step that we have to follow. Any doubt with this? Got it. Now comes to the rule. Please make a note of this rule one by one. There are 4 rules and based on that we are going to solve the example also. First rule is if a pair is selected, okay, if a pair is repeated letters, if we have a pair of letters, insert a filter like X. For example, if the word is balloon, then it should be BALXLOON. This X that you are looking at, this is only available because there is a repeating L which you are observing over here. Understand? So this is the first rule that please make a note of. If a pair is repeated letters, then insert a filter like X. For example, you can see hello, H-E-L-L-O. So H-E will be 1, L-X will be 1 and L-O will be 1. Because we are going to have 2 bits at a time. So like diagrams. So basically 2 alphabets we have to consider. See, if there is any scenario where there is a single digit, we have to make sure there is some dummy bit along with it. Especially for the fact whenever we have this LL, like similar letter, we will use an X as a filler. Second rule is, yes please. It's just a rule. It's nothing that this is nothing to do with the key set. This is not the key set. I'm talking about this is the plain text. In the plain text, suppose you have 2 letters common, then you can replace that by an X. 2 O's where? But in that case, if you are using LX, you are making ON, right? Like here, if you are using L comes in early than that of O. So you are utilizing LX, LO, ON. So basically, you have to observe that whether you are able to find a 2-letter word. Since LL is coming before OO, we are making that X appending with L. Yeah. So that's what we are trying to do. This is with respect to the encryption, the plain text we are talking about. When the plain text is going to get segregated into 2 halves, I'll just show you one example maybe. Before that, maybe we can start off. You can see instrument. This is my plain text. Right? Suppose, we'll come to that later. So plain text is instrument, so we are basically dividing it into 2 halves. During this division, if suppose you come across that there are 2 letters which are together, then we can filler it by an X. That's the rule. This is not the first rule doesn't apply for the key set. It's only for the plain text. Right? So this is the first rule. Second rule is, if both letters in the table, in the key set, fall in the same row, just write it down in a short way. If they fall in the same row, then replace each letter to the right. Whatever the letter we have, replace it with the right, wrapping back to start from end. That means that if you can take an example here, A and R, they fall in the same row. So what we have to do as per the rule, A will be replaced by R and R will be replaced by M, because the wraparound condition will be there. So suppose given a condition where you are looking at a scenario where the 2 letters are forming. So first you have defined it with 2 letters together from the plain text. Now those 2 letters will be compared and checked from the key set that whether those 2 letters form in the same row or not. If they are falling in same row, then you replace that by the right hand side letter what is to be there. Simple as that. For example, FG or rather HY. This will be easier. HY if it is there, then H will be replaced by Y and Y should be replaced by V. That's the rule. If supposing some example comes. So please make a note, if in same row, take the right element. That's the only thing that you have to write. Third rule. If the letters fall in the same column, same way, downward we will go. That means replace each with the letter below to the letter we are looking at. For example, as you can see, N and U. M is over here, U is over here. They fall in the same column. So what you have to do is you have to wrap around. For example, M needs to be replaced by C and U needs to be wrapped around like this. So UM comes in here. So instead of MU, now it is going as CM. Same rule. Right hand side we are going in the second rule row wise. Now column wise we are going in the same way, downward. C is replaced by M is replaced by C and U is replaced by yes. Now the last rule is the exception, that is if suppose it doesn't fall in the same row, if it doesn't fall in the same column, that is the else condition. No condition at all. Then we have to do otherwise is the exception. Each letter is replaced by the one in its row in the column of the other letter pair. What does that mean? that suppose for example H and S, see the example, H and S, H writes here, S is somewhere here. Okay? Now if you go back, where these two will intersect, H, because H is the first letter, we will go this way and we will come like this. So B is the letter where they will intersect. So we will consider B as the letter that will replace H. Because H and S doesn't fall under the same row, neither in the same column. So wherever you are going to intersect among the two, and in that also the order needs to be maintained. H is the first letter, so we go right hand side we start from H, we go towards the right. Because left side if I go, there is no meaning to it, it will never intersect. H we will go this way, S we are going to come, wherever it will intersect, that letter will be considered. Same like the first table based Vignere cipher that we have done, very similar kind of approach. And also if you observe for S, what will happen? For S we will go this way, and H we are going to this way. So P becomes the element which we have to consider for replacing the letter S. Why we went this side? Because in that case S is our reference. From S we start, we go towards left, we come down towards from H, wherever it will intersect, that will be the letter that will. I have given another example, E and A. Check for yourself, E is somewhere here, E is here, A is somewhere here. So what will be the value? You go this side E and you come down this way. So I or J, you can see you can take anything as desired. So it can be IM or JM, anything is fine. You can see that or I mentioned. And the M can also be found out. See, the M is common for both the things. Clear with the idea? 4 rules are there. If that is the case, can you solve this for me? You have the plain text. This is where we end our discussion with. Plain text is instruments. Plain text is instruments. The first step of the process is that we have to dissect that plain text into digit or digit or diagrams. We call it in alphabetical term. So you can see in, in, st, ru, me, nt, sz. See the last letter. If I go by 2, there is a process in which s is becoming alone. So we have given a dummy bit x or z or anything. Basically which doesn't have a very high probability. That's what the rule is. As per the frequency, the letter alphabet which comes very rarely, we are going to utilize that. You can see in this example, last page, what is your name? I forgot. Yeah. See this example. This last one, instruments. S is where we end. S, if I go by 2 letter, at the last S, we don't have any single to append. So what we have appended, we have appended at Z. Any letter we can use, X, Y, Z, these are very rarely used. So that's why we are appending it. Right? So that's an example. So now we have 2 digits. So every diagrams are done. Now monarchy is the key. Same thing, since we have taken that example and the key set is already there. So first of all, can you tell me that what will be the rule that will be applicable when I consider in as the first diagram, and what should be the necessary encrypted alphabet? You can observe over here, I have specifically mentioned green colored element which indicates the present diagram. So you can observe in over here is colored as green. So I is over here, N is over here. Do they form the second rule? Are they following the same row? No. Are they following the same column rule? Third rule? No. So basically they are following the fourth rule. That means they are not following second rule, that is they are not in the same row, neither they are in the same column. So what we have to do is we will go this way, and N we are going to go this way, and we might get an A over here. Okay. Or in that way, what we can do is in fact we can go this way. We are going to start right. So we are going to go this way. N we are coming down like this, and we are getting a G. So GA forms the basis of the first encrypted. Fourth rule, that's why the 4 is mentioned over there. So rule number 4 is applied, and we are observing that for both this letter GA forms the encrypted bit. Can you tell me for ST in the same manner? The second diagram, I think in really ST is mentioned over here. So it is the which rule you are going to apply? Same row. So most probably rule number 2. What was the rule? S is to be replaced by T, T is to be replaced by L. Third one, RU. R stands here, U stands here. Fourth rule, NZ. NE, next one. Which rule we are going to apply? Third rule, because they are in same column. They are in same column. Now NE is the element. So N is replaced by C. That's why you can see C is colored as red. And E is replaced by L. So your element should be C and N. Next one, NT. What rule where it lies? N is somewhere here. T is over here. It's almost the fourth rule again. So it should be 4. I made a mistake. That should be 4. And the process should be R and Q. That's the encrypted data. Okay. So this should be 4 actually. Okay. And finally SZ. S is over here, Z is over here. Again the rule number 4 should be applied, and we are getting a value of P and X. So using this process, what we are observing is that this is a very interesting way in which we are making sure the ciphertext has got a different set of rules used for every 2 alphabets that we are considering. Every two alphabet will have a different rule that we are setting. That's why the cryptanalysis for this kind of an alphabetical polyalphabetic cipher is always relatively difficult to crack. Okay, so this is much better compared to the previous example that we are found. Okay. So on Friday's class, when we are coming back, I will give you some more examples on this, and we will solve some more numericals till this point, whatever we have discussed. Alright? Thanks.